vertical circular motion. Again, basic premise is that you should be knowing what is centripetal force. Okay.
Sir.
So,
Hello,
yes.
sir. I had one doubt. Ki when you have a body in circular motion, what if it has a velocity in another direction also? In the mv square by r formula, do we consider only the perpendicular velocity to the?
Yeah, tangential velocity. Okay. So, suppose you have the body over here, and suppose at that instance it had got a velocity v this side. Okay. And suppose you want to find out the centripetal acceleration with respect to this circular path. Okay. Then you will take this component of the v. Okay. V tangential and m v tangential square by r will be your centripetal force. Okay.
Yeah.
Okay. Yeah. Is this recording, guys?
Yes.
Yes, sir.
So, yeah, just to complete the last thing, what he was asking, suppose you have the velocity this way and there is an acceleration also this way. Okay. V is changing. So we don't care. What is the V at that moment gives you the centripetal acceleration. AC will be V square by R. Okay. And A tangential is there, then very well. A tangential is there. A tangential. Net acceleration will be somewhere over here. Vector addition of this and AC. Okay. So this square plus that square under root. Okay. So a lot of questions comes on that also. Okay. But centripetal just cares that at that instance, how much was the velocity, whether it is going to increase or decrease, that is none of the business for centripetal acceleration. Okay. Is that clear, guys? Is that clear?
Yes.
Okay. Now, the point that centripetal acceleration is the net force towards the center and it is not a separate force. It is all forces toward the center together is called a centripetal force. Okay. It's going to be explored in this part big time. Okay. So suppose the body was going in a circular motion. One second. It was going in a circular motion by a string which was attached. Okay. So at this instance, it is having a tangential velocity this way. What do you think? There's a string attached and that is going in a circular motion. Okay. What is the centripetal force? Who will say?
Sir, could you repeat the question?
This black body is having a string attached. Okay. And the string is being whirled round and round. So the body is going round and round. It has got a certain velocity at a certain instance, say v. What is the centripetal force? What are the responsible forces for the centripetal force? Who can say?
Sir, tension.
Sir, tension.
Are you sure? That's it?
Sir, mg.
Huh?
Sir, mg.
Full mg?
No, sir, the component along tension.
Yeah. So that is what is being explored, okay, fully over here. That we will see what are the forces. One is tension is there and nobody is stopping the weight. Mg is there. So the centripetal force must be equal to the net force along this line. What is that? T minus, suppose this angle is theta. Suppose that angle is theta. Then T minus mg cos theta is the centripetal force, which must be equal to mv square by r. Is that clear, guys? So you see one force which is the center and don't jump and say that that is a centripetal force. Is that clear, guys? Is that clear? Is that clear?
Yes, sir.
Another
Yes,
way
sir.
of looking at it is, if a body was going with v velocity, somebody must provide this much of a force, mv square by r force. Okay. So the minimum criteria of the force for body to make a vertical circle is, it happens to be here right on the top. Why it happens to be there? Because when it is crossing the top, we have tension downwards, and what else downwards?
mg.
We have mg downwards, right? If we say that what should be the velocity, minimum velocity on the top, just that it takes a circle, then for any velocity it is mg plus t is equal to mv square by r. Okay, that is for any velocity. If we lower the velocity, what is going to happen? Will mg lower? Will mg become less?
The tension will become
No,
less.
the tension will become less. That you can feel, okay, when you are whirling it in vertical. You still lower the velocity, tension will become even less. Okay, still lower the velocity. So at the lowest, you can make tension 0, and mg is alone taking care. mg alone is taking care of the vertical motion's centripetal force with the lowest velocity possible. If we lower further than this, what is going to happen? Then there is no force which can provide the centripetal force required, mv square by r, and hence the body will not go in a circle. Okay, are you
Sir,
understanding?
as soon as the tension becomes zero, it will not go in circular motion, right?
No, that's wrong.
Like just
If
after that.
it is just for the circular motion, okay? Because if the
Oh, yeah,
tension
right.
is just 0, then just before it there will be a tension. We'll do that calculation if required. Just after it there will be a tension, and only at this moment, momentarily, the tension is becoming 0, but mg is able to maintain it in a circular motion, and after that tension will also come into play. Okay, is that clear?
Yes, sir.
So in the vertical, the centripetal force is provided by mg and t. So for minimum velocity, mg should be the guy which is providing the centripetal force for the lowest vertical velocity on the top. Bottom is not a big criteria, it's not a big headache at all. Why? Because tension will always be there. You can just physically feel it, that if you are taking it round and round, the string has to be tight at the bottom. It will become tight. The reason is that mg is down, centripetal force has to be upwards. So if there is no tension, there is no question that the body is going in a circular motion. Okay, so tension is there, tension is the main guy. Mg is in fact opposing it. So mg minus t minus mg must be equal to mv square by r. Okay, so t is always there. Okay, so at the bottom, in fact, the tension is maximum. Why? Because tension is mg plus mv square by r. Weight plus the, you can say that the centrifugal force which is acting, pulling it outwards. You can say in that way. So tension is very, very high. So the questions which come in circular motion is that very cheap kind of questions. I'll just do the question straight away because we don't have time. The question comes that what should be the velocity over here such that it completes a circle. So very easy. First we'll write a energy equation. Say here the velocity is v. Here how much would be velocity, just so that it just completes a circle. So we'll say that bottom, the total energy was, if we consider this as 0 level for myself, potential energy wherever you can consider 0 level, then the total energy at the bottom was 0 plus half mu square. Total energy over here is how much? mg 2r is the height, 2r, diameter is the height, plus half mv square. So initial energy and final energy has to be same. So you have dropped in velocity has become less, but so this kinetic energy has become less, but potential energy has become more. That is one equation. Okay, so if you just tidy up the equation and write, then it is u square is equal to 4gr plus v square, right? Is that clear? And another thing is, if it is just completing a circle, we just said that mg plus t, but then t has become 0. Mg plus t must be equal to mv square by r. Is that clear? So mm gets cancelled, m and m gets cancelled, t is 0. So we get v square must be equal to minimum gr, so that it completes the circle on top, right? So if you put that v square value over here, then we get u square must be equal to how much?
Root 5 GR.
Yeah, 5 gr should be your u square value. Okay, so this is very, very common, that what should be at the right at the bottom. Okay. So they can do any variations of the question. So what should be the velocity of the bottom such that on the top is a minimum tension of say 2 mg or something like that. Okay. Then instead of putting t is equal to 0, you'll put t is equal to 2 mg and do it. That means they are just testing that you have mugged up 5 gr or you know the concept. Okay. Is that clear? That's your vertical circular motion. Any doubt? If you have, you ask.
So can you just like repeat how you got 5 GR?
I have a longer and fully done video on this with some batch. Okay, you understand this equation?
Yes, sir.
Yeah, what is this equation? Tell me.
Sir, it's like half. We're using the energy thingy, like
Yeah,
0
what
plus
is that
half.
0? What is that 0? What is that half mu square? Just tell me each and everything in words.
So the 0 is the tension, not tension force. That's energy, right? And
What energy? Why have I written a 0 over there? So ask me, no, when you're writing. And don't be convinced that, yeah, I know that equation. Say properly. I had written this. So you have to follow
it's the
fast.
bottom point. So potential energy is 0, and then like half mu square is because of the velocity.
Yeah, so this is the total energy, potential plus kinetic at the bottom point. What is these two parts? mgh. Okay, h happens to be 2r, right?
Yes, sir.
R is the radius. So potential and kinetic at the topmost part. What is this equal to? We are saying that there was no friction, nothing in between, and hence the initial energy must be equal to the final energy. Okay, is that clear?
Yes, sir.
So if we just cut the m and multiply 2 all over, we get this. U square is equal to 4gr plus v square. Any doubt? Any
Sir,
doubt?
how did you get the mg square r part?
Mg square r, where is that?
0 plus half mu square is equals to mg square r.
That's 2r square r. It's mg into 2r. That's the height.
Oh, okay.
mg into 2h, mg into 2r, no? Just now I said, no? mgh, h is equal to 2r, right?
Yes, sir.
Yeah, don't just look. Don't look. You do yourself. Don't copy at all. Look at the actual thing and you yourself write that, sir, it should have been mg into 2r, no? Why did you write mg square r? You should have said mg into 2r, it should be, right? Like that. Okay, not like asking why it is mg square r. Obviously, it cannot be mg square r. So there is no question of why it is that. You have to say it should be this. If you are understanding that there is a potential energy, then you should say that it should be this written over here. Okay, do you understand this line?
Sir, u
You
square is
understand
equals
this line?
Yes, sir.
Yeah, okay. You understand this line?
mg. This thing, no, sir, not really.
So what are we writing? At the topmost
Oh,
point.
at the topmost point. Yes, sir. mg plus t. So if
So
what
if
we
it's
can
just crossing, then t is 0. Okay. If it is crossing with very good velocity and t is tight, string is tight, then there is some t. Okay. If it is just crossing, then t is just 0 over there. Is that clear? So
Yes, sir.
mg plus t was the centripetal force. So mg plus t is equal to mv square by r. In this question, just crossing is asked, then we can very well put t is equal to 0, and that is the thing. Is that clear? Is that clear? So v square is gr. You put that v square gr in this equation, you'll get this. That u square is equal to 5gr. Okay. Now my question is that if u square was equal to say 3gr or 4gr, if u square was equal to 3gr, where will the string become loose? It will definitely not cross the circle, right? Right?
Yes, sir.
It go up till here and become loose. Like the thing may go up, body is going up, and become loose and just fall down, right? Say 4gr, it may go till this point and become loose. Okay. It will follow the circle to a certain height and then become loose because the velocity is not enough at the bottom. If it is 5gr, then yes, it is going to go and cross the circle, and then after that again the string starts becoming tight. It is just the topmost point. Crossing the topmost point is the most difficult because there the velocity is the least. Okay. Is that clear? Is that clear? So how to do this? So those who have understood very well will try to do this. The thing is, you will imagine that okay, it becomes loose at a certain angle theta. Okay, and at this angle theta, you do your mv square by r, you do your component of mg here, and you do your t, and since it is going to become loose, you put your t is equal to 0 here. Okay, so what is this? This is your mg. So what is the component of mg over there?
mg
This
sin.
will be 90 minus theta. So mg cos 90 minus theta is mg sin theta. So your equation will be mg sin theta plus the tension, which is 0, is equal to mv square by r towards the outside. Is that clear? Is that clear? Is one equation. Okay. What is the other equation? The height, the energy equation.
Energy.
What is the energy equation? The energy equation will be half mu square at the bottom, and there the energy will be, one is half mv square. Okay, very well, plus mgh. What is the h? Radius plus r sin theta or not?
Oh, yes.
So somebody is able to write these two equations, end of story. Becomes a decent high level mains question. Okay, and to make it an advanced question, they will say, okay, where does it fall on the ground? So it becomes a projectile after this. Since the string has become loose, it becomes a projectile. After getting the V, you have to do as a projectile question. So that becomes like an advanced question. Is that clear? So when we are talking about this point and this point, it's like a bit-sat level question or a NEET level question. A proper mains level question is, before that, at a certain angle, you have made it loose. In a NEET also, it can come.
Sir,
Okay? And advanced is, it makes a projectile. So there are various levels of questioning on the same thing. Okay? So you don't ask me that how did you do this? Not at all. I just said something. You may just rub it off and do yourself. What is being taught is this. And this is just, I gave some hint. You rather don't note down and you do yourself and show it to your teachers. That, sir, this is a question. I did it. Is it right? Is it wrong? Okay.
sir,
Hmm.
sir, can you explain the r plus r sin theta?
No, I said no. I cannot do that. Who is that?
Sir, Anish.
No, not at all.
Okay, sir.
You have to do yourself. No, you have to write these two equations for that situation yourself. One is the energy equation, and one is the centripetal force is equal to the net forces towards the center equation. Okay,
Okay, sir.
and you'll get some kind of these two kind of equation. Okay, maybe I have written it wrong. Okay, maybe this is all incorrect. You write correctly. Okay,
Okay, sir.
energy and centripetal force equation. So that's your motion in vertical. That's it for the day. If you have any doubt, You can stay back and ask. Otherwise, tata bye bye.